Now let's say that we have an image of a scene, and at a particular pixel in the image, we measure the brightness value to be 65. Now the question is, what does that number 65 tell you about the corresponding point in the scene? This is the problem of image intensity understanding. And before we can tackle the problem, we need to understand two things. The first is what we call radiometric concepts. That is, concepts related to light, the brightness of light sources, the brightness of scenes, and so on. So we'll go through some of those definitions and concepts. And the second thing we need to understand is the ability of a surface or a material to take light from one direction and reflect it in a different direction. And that concept is called reflectance. So we'll look at reflectance models in this lecture. So first, let's take a look at the problem of image intensity understanding. Here is our typical vision system. We have a three-dimensional scene, and we have some form of lighting. I'm showing here a simple point light source, but you can have multiple point light sources, or you can even have what are called area sources or extended sources in the scene. So the light from all of these sources falls in the scene, and let's take a look at a single point in the scene, which is this one right here. This point receives light from the sources and then reflects it or scatters in different directions. And the light that is scattered in the direction of the camera is projected by the lens of the camera onto the image plane where you have an image intensity value. And the question we're asking is, what does this image intensity value that we've measured here say about the corresponding point in the scene? So let's take a look at this problem in greater detail. This is called the image intensity understanding problem. You have, for a given point, let's say this is the point of interest to us, it lies on a surface which is made of some material, and it has a surface orientation given by this vector n. And we have a light source, a simple light source, in this case a point light source. It illuminates this point, and the point then reflects light in the direction of the camera, and that produces the image intensity corresponding to that point. So what are the factors that influence the image intensity of the point? Well, first, of course, you have illumination. You could have simple illumination, which is a point light source of a certain brightness in a certain direction, or you could have multiple point light sources, or even extended and array light sources as well. But whatever the case may be, you can imagine that you need a certain number of parameters to define the illumination itself, which are unknown to us in this setting. And then, of course, you have the orientation of the surface at that point of interest, which is given by n. So that's an additional couple of parameters. And finally, you have the ability of the surface to take light from one direction and reflect it in the direction of the camera. And that's given by what's called the reflectance, the surface reflectance of the material that the surface is made of. And that could have many parameters associated with it. So you quickly see that you have one number on the left-hand side, but you have many unknowns on the right-hand side. And therefore we can say that image intensity understanding is a severely under-constrained problem. But it turns out that under certain settings and with certain assumptions, we can actually say quite a bit about the corresponding point in the scene from even a single intensity value. So, in this lecture, we're going to talk about the fact that if we want to interpret image intensity values, we really need to understand two things. The first is radiometric concepts, and the second is the reflectance properties of surfaces. So we're going to start with radiometric concepts. We want to be able to say in some quantitative manner, what is the brightness of a light source? What is the illumination of a surface? What is the brightness of a surface? So we will define various radiometric concepts that allow us to quantify these different concepts. And then one of the interesting concepts here is called surface radiance. That is a definition that is used to measure the brightness of a point in the scene. So we can say that a surface point has a certain radiance, And now the question is, what is its corresponding image brightness or image irradiance? So we're going to spend some time on the relationship between surface radiance and image irradiance. Of course, you can imagine that if you increase the brightness of a point in the scene, probably the brightness in the image is going to increase. That's what we experience on a daily basis. But is the relationship linear or is it non-linear? We'll derive the relationship. Once we have that in place, we're going to talk about reflectance. In particular, the bidirectional reflectance distribution function, which is a function that completely describes the ability of a surface to take light from one direction and reflect it in another direction. Once we've done that, we can start looking at what are common reflectance properties that are encountered in the real world. And that brings us to reflectance models. We look at particularly surfaces that are diffuse or matte in appearance, as well as surfaces that are mirror-like or shiny in appearance. And then we'll also look at models that cover both of these at the same time. So we'll look at some very widely used reflectance models, both in computer vision as well as computer graphics. And then finally, we'll take a look at how the reflectance of a point is impacted by the illumination color itself. So how does the color of the illumination get modified by a surface to finally produce a color in the image? That, in our case, is given by what's called a dichromatic reflectance model. We'll also see how the dichromatic model can be used to actually take a single image and separate it into its reflectance components.